Hey there, Math Niners. It's Mr. Bleeker here. I'm going to do something a little bit different. I'm going to record what's called a screencast, and the reason I'm doing this is because I want to record a math lesson and make it like a digital resource for the class. So, I'll teach this lesson, more or less, with my iPad, and I'll be able to save it as a movie. That way, in the future, if you ever need to go back to this lesson or just sort of see it replayed again, you can go back, check it out, and it really helps, especially if you're away. Okay, so let's get going. So, lesson 2-1 is all about using these things called rational numbers. And what we want to do is get a sense of the size of rational numbers, like which ones are bigger and which ones are smaller and which ones are in between. And it kind of helps to look at rational numbers in decimal form. So the thing about rational numbers that I wanted you guys to be aware of is that rational numbers are kind of an interesting term. When we talk about a rational number, what we're referring to is a rational number. So rational. So first of all, think about what a ratio is. A ratio, more or less, is just a fraction. And fractions can be written with the numerator, I'll let that be represented by A, over top of a denominator, which we can represent by the letter B. So if we're going to compare rational numbers, we're just more or less looking at the size of fractions. Now, because fractions and decimals are just different versions of each other, we have to sort of expand what we're looking at for our comparison. So in this list here, it's going to ask, well, what's bigger and what's smaller? The first thing a lot of students will do, they'll say, well, let's just make them all decimals, right? And then we can figure out just how big these things are. So if they're all pure decimals, sometimes it's a little bit easier to see for the average person, right? So what they've done, we'll go down here to item 1, is they're all in decimal form. Okay, so that half that you see above, let me just sneak a red color here, if I can get rid of that. This half right there this guy here has been converted to 0.5. So if you take 1 and divide it by 2, you get 1/2. Now when you go to compare these numbers, they're not in order, but what you've got is you've got a half, -4, +2.5, and 0.25, which is the same thing as a quarter. So as far as this goes, you put on a number line, if you think about it, if 0 were in the middle, then your most negative numbers are pretty far on this side, and your most positive numbers are over here. So in this case, if we reorder them, we'll put the -4 here, and then we go back to the list and we say, what is the next smallest number? Well, the next one is 0.25, right? If you have a quarter, that's not nearly as big as half a dollar, or 0.50 cents. And I would like to have $2.50 if I could swing it. So this is in order from smallest to largest, which I'll represent with these letters like this. Okay, now what is also fair, instead of just converting to decimals, one thing that you can do is you can convert things, we'll go to blue this time, you can convert these things entirely to fractions. Now, if you convert them to fractions, one of the biggest things you have to be aware that you have to do is if you're going to compare them, they had all better be out of the same value. So what I'm saying is these numbers here, this is 1/2, for example, and -4, any integer, positive or negative, is understood to be over 1 as a denominator. And when we look at a few of these values, for example, when we look at what is 2.5, 2.5, if you want to determine its fraction, you can think of it as being 2 and a 5, and the last decimal bin is tenths. There you go. 25 over 10, because the last decimal bin was tenths. If you reduce this, take it down, and reduce the fraction, you get 5 over 4, about like this. So it might have been a little while since you've seen this. And it's only 25 over 10, because what's on the bottom here is the last decimal bin in which a digit landed, in this case 5. So it's 25 over 10, tenths bin. A quarter, you can think this one here, a lot of us can recognize this as being 1 over 4. Now, if it's 1 over 4, 0.25 is like having 1/4 in your pocket. That's sort of a quick way of doing business. A quarter, if you take a quarter and it needs to be out of 24, the only way to get 4 to 24 is to multiply by 6. And the rule is what you do to the bottom, you do to the top. And that's how you get 6 out of 24. Okay, so this takes a little bit of work, but now that they're all now that they're all converted, 1/2 is like 12 out of 24. Okay, 12 is half of 24. -4 over 1, this might look a little strange, but where'd that come from? -4 over 1, well, we had to get it out of 24. So you had to do this adjustment. And you have to inflate the top and the bottom by the same value. Otherwise, you've treated your fraction unequally. So this is how you got -96 out of 24. 5 over 4 converts upwards. If you're going to make that out of 24, you have to multiply by 6. And now you've got 30 out of 24. And your last one, 6 out of 24, you didn't have to adjust, so you can put it like this. So I'll just do a little erase here so I can just sort of see a little bit better now that we've seen where our values come from. Okay. So when you look at them and you go to rank them, now you can see what's the biggest and what's the smallest. So let me just choose a new color. Let's go with this sort of burnt orange. This one is extremely negative. It's a very small value. So we put it first in the negative list. Okay, so you can cross that out. Now the next value, 6 out of 24, is a lot smaller than either of the other two. So I'm just looking at the numerator now. Now that they're out of 24, -96 is the smallest number. We've got 6 out of 24. Well, that there is bigger than -96, so it's next in the list. Cross that out. Between 12 and 30 out of 24, I'd say the 12 out of 24 goes there, and the last one, largest value, 30 out of 24. Okay, so lots of scribbling on my sheet. It is fair to say that using decimals, it's quick, it's easy. You can put 1/2, you shouldn't even have to convert that with a calculator. You can put these all in decimal form and order them fairly quickly. But fractions themselves are very, very useful. Some decimals, like 0.3 repeating, come from fractions like 1/3. And you'll find that with some of these repeating fractions, it can get a little bit hard to determine, what is bigger than what. We'll handle that as we go along. Move this up a little bit. Okay, so let's grab a new color just for fun. Dark purple. So rational numbers are any number that can be expressed as one value over another value. Okay, so we'll represent the first value, A, being the numerator, B being the denominator, where A and B are integers. What does that mean? It means that A and B need to more or less be positive or negative whole numbers. Okay, so an example of a rational number, -1/3, right? 2/5. So the top and the bottom are clean values. They're just integers. When you look at a non-rational number, it's something where you can't express them, the fraction, cleanly. For example, pi. Okay, it's not rational because pi, the closest thing to it, is 22/7, but that isn't fully correct. When you look at any irrational number, and that's what we're talking about, pi comes out to 3.14156, yada, yada, yada. It goes on forever. So the problem with that is because it doesn't have a final decimal bin, I don't know what the fraction should be. It's really hard to say because I can't get the denominator figured out. It's irrational. And you'll find that other irrational numbers, if you take the square root of 5 or any prime number like square root of 3, you will get an awful repeating decimal pattern, and there's no way, it's not like 0.5, right, where you can say the 5 is in the tens column. See, this is very tidy because you know what the last decimal place was. That's where the 10 comes from, 5/10, which reduces to 1/2. So because you don't have a finalized decimal position, you can't determine what the denominator is accurately. Okay, so I need to do a little eraser-rooney here. Okay, and that'll have to do. All right, go back to purple there. Okay, so when you look at ascending numbers are numbers that increase. So if we were looking at ascending values, I could say, well, a quarter. Oops, go back to drawing. Let's say we had -1/4, and then you had 0, and then you had 1/2, and then you had 3/5. So they're getting bigger. They're getting bigger as you go this way. Descending values are when you look at large values that become smaller. So if I was to go in descending order, let's say they're test scores, and I'll just make them out of 20. Let's say they were quizzes out of 20. You could have 18 out of 20, and then you could have 16 out of 20. Let's say not such a good score, 8 out of 20. And let's say 4 out of 20. So descending, going down. Okay, so instead of ascending getting large, descending becomes small. And that's your smallest value. Okay, so when you go to list values in ascending order, you say, okay, what is the ascending order? Since these are decimal values, what you can do is you look for the smallest one first, and you look for the largest one last. So when you peek into this group, when you look at these values, you look for the largest negative value. Now this is kind of sneaky. This is 0.001. 0.99, and it's negative. As soon as I put that 0 in, you can figure out fairly quickly that this is not as big as -1. It's really close. So let's start with the smallest numbers. We've got -1, then we've got, put a comma, negative 0.99. Okay, so I like to cross them out as I go along. This is just a little bit on the left of 0, so negative 0.004. Next value, 3.5 is smaller than 7, and then we have 7. Okay, not too bad. Now, since I'm actually working from home, what I would ask you to do is take a look at page 48 and do the practice called Show That You Know. It's on page 48. This is where you test yourself. All right, now we get back to something that you're supposed to know quite well, and it's the old alligator mouth. Well, that's the way I was taught. Kind of a neat thing. Some of you might have heard of Pac-Man. It doesn't really matter. What means, and I always like this, the mouth, the smaller one tries to eat the larger one. So the rule is the smaller one is trying to do the eating. It's jealous of the larger value. And I know that sounds kind of weird because, for example, large fish eat smaller fish. Don't think of that. Just think that the small fish are envious and they'd like to eat the larger ones if they could. So 4 is tinier than 8, and -4 is smaller than -3, because on the number line, -4 is there, -3 is there, and the larger values, for example, -2, -1, and even 0, they're bigger. So when we look at this greater than and less than sign, we would say that 4 is less than 8, and we could say that -4 is less than -3. And there's different ways of saying this. You can say, okay, instead of less than, we turn around and we say, all right, who's bigger? If we do that, we could say that -3 is greater than -4. It's just how you look at it. It's how you describe it. You can say who's smaller or who's bigger. So let's see what we can do here. When you compare negative fractions, which is one of the things you'll be asked to do, how do you go about doing that? So what's smaller, -2/3 or -4/4? Well, you've got a lot of choice. One of the things you could do is you could just put them in decimal form. 2/3, if you divide it on a calculator, is 0.66, and it repeats. So I'll go like this. And remember, it's negative. And -4 over 4, well, if you go 4 into -4, it goes in one time, and the answer is negative, because a positive and a negative, remember, in multiplication, one of the rules is when you multiply a pos and an egg, whenever you multiply or divide, the answer will be negative. So -4 divided by 4 is -1. Now I just have to do a little cleanup here. So if we compare these two, think of a number line. Who is further, let's say zeros here, who's more negative? This is about -2/3. So say that's -1, -2, -3. -1 is here, right there. But this, this comes up just a little bit after a half, right? It's right about there. Okay, so if this side is positive, the closer you are to positivity, the bigger you are. And this side is negative. So if I went to put a who's bigger sign in between these two, let's change color. So let's go with a nice red. -1 is smaller, and the smaller thing is envious and tries to eat the bigger one. So in this case, this right here is bigger because it's closer to the positive side. Okay, so you notice that I put these in terms of decimals, which is what I think a lot of you are going to do. So let's go on with something like example 2. Identify a rational number between two given rational numbers. Okay, so what they want you to do here is they're saying keep it to fractions. And that takes a little more work. So I'll go with black this time. Now, 1/3 and 5/6. 1/3, if we're going to compare fractions, we have to make them equivalent. So first thing I'm doing, you have to multiply 3 times 2 to get it out of 6. If you look at it, you've got 2 out of 6. Well, you can get back to this value here if you divide 2 out of the top and the bottom. But we need them to be out of 6. So we look at 2/6 and 5/6. And once they're out of 6, you can see which is larger. If all we need to do is just get one more out of 6, and this would be a whole value. So poor little 2 out of 6 is smaller and is envious and wants to eat the more superior 5 out of 6. Pretty straightforward. Okay, so at this point, we've more or less come to the end of the lesson, and you get a chance to do the old show that you know. Let's pick a nice drastic green here. So you go to page 50, and there's an example there that you can work through. Sorry, I don't have the graphics, so I won't do it from here. And there's some key ideas there to take in. So read that over. Now, the assignment here is numbers 4 to 27 on page 51. So I always like to get rid of that. Let's go back to red for a second. Page 51, numbers 4 to 27. So that's quite a bit of work. So if they are lettered items, let's say one of the questions has A, B, C, D, and you know, these things can go on forever. I will allow you to do what's called ACE. And I think you probably figured it out pretty quick. Yeah, change my color. If it's ACE, then that means, as far as letters, just do these ones. And that's my way of reducing your assignment. Okay? So you have to do numbers 4 to 27, and if there's any lettered items, you can do A, C, and E items. All right. So I hope you enjoyed my screen narration. You can watch this as many times as you want. I don't know if you can stand it more than twice, but I invite you to give it a whirl. Okay, this is Mr. B signing off.